Bismillahirrahmanirrahim. Hello everyone. This is the method number 6, which is Laplace transform method. Let's see how can we use it to solve a linear Volterra integral equation. As always, these are the steps of the method, and our method is Laplace transform method. So what's the first step? The first step is to get the Laplace transform of the integral equation, and that's by applying L, which is Laplace operator, on the integral equation, and then you put Lu of x in one side of the equation. Okay, we can write it Lu of x or us. Okay, U capital of s. The last step, you get the inverse of Laplace transform, which is mean applying L minus 1, which is the inverse of the Laplace operator. As always, the examples are two groups. The first group I will solve it with you, and the second group you will try it and check out if you can do it yourself or not. Tell me if you have any problem in solving those examples yourself. This is Volterra integral equation, and we need to solve it using Laplace transform method. Okay, we need first to draw this aside so it can help you if you do not remember. If we have f of x, then its Laplace transform form is f capital of s. Okay, and if it's 1, then it's 1 over s, and if it's sine x, then it's transformed method. Its transformed form is 1 over s squared plus 1. What if it is cosine x? Then it is transformed as s over s squared plus 1. Okay, so let's first apply the L on our equation. We'll get u of s equal to 1 over s plus 2. Let's transform sine x, which is gonna give us 1 over s squared plus 1 minus, we have here this integration, which is from 0 to x. We'll apply L on it. Let's write x minus t raised to 0. Okay, here u of t dt. Okay, when I write it this way, I write it in the form of convolution. Okay, it's as if there is a function which is x minus t raised to 0, which can be written in the form of x minus t. Okay, so it's as if fx minus t, okay, multiplied by u of t, and it's inside this integration. And of course our f of x minus t is x minus t raised to 0. Okay, when we transform this using Laplace transformation, it gives us what? It gives us fs. Okay, multiplied by us. Okay, so this is the transformed form. Okay, so let's write it down. We'll have us equal to 1 over s plus 2 over s squared plus 1 minus 1. Of course, here this is 1L1, which is 1 over s. Okay, Lu of x or u of t, it will give us us. Okay, now we need to put u of s all in one side, so let's take this one the other side. That will give us us as a common factor. 1 plus 1 over s equal to 1 over s plus 2 over s squared plus 1. Now we have here, it's as if as we are saying s over s plus 1 over s, which is mean what, s plus 1 over s. Okay, we want to get rid of this, so we will multiply by s over s plus 1 for both sides. Okay, and that will give us us equal to s over s plus 1 multiplied 1 over s plus s over s plus 1 multiplied by 2 over s squared plus 1. And this will give us s, we'll go with the s. Okay, and that will give us s plus 1 over s plus 1 plus 2s over s plus 1 multiplied by s squared plus 1. We want to add this term with that term, so we need to make their denominator the same, so we will multiply here by s squared plus 1 up and down, s squared plus 1. Okay, so that will give us s squared plus 1, let's write it, plus 2s plus 1 over s plus 1 multiplied by s squared plus 1. Okay, and if we factor this, this will give us s plus 1 squared, so one of them will go with the one downstairs, and that will give us s plus 1 over s squared plus 1. Let's disturb the numerator over the denominator. We call this in Arabic توزيع البسط على المقام. We get s over s squared plus 1 plus 1 over s squared plus 1. Okay, now let me clean up place and then complete. So now we have u of s in one side, and we have this very explicit form. As we can see, the first form here is for cosine x, which is s over s squared plus 1, and we have 1 over s squared plus 1, which is for sine x. So This is very easy. Now we will use L minus 1 and we will get u of x that we want, which is cosine x plus sine x. Okay. Before solving this integral equation, we need to remember that f of x, when it is sin x, its transformed form is 1 over s squared minus 1. What if it's x sin x, which is x multiplied by the f of x, and in our case the f of x is sin x? What should we do? We should use this method, which is L to x multiplied by f of x will give us minus fs. Okay, so you can get x sin x if you know only sin x, and x sin x is equal to Lx sin x is equal to 2s over s squared minus 1 for all squared. Okay, so now let's apply L. Okay, on the equation we get us equal to 2 L1, let's write it like this, minus 2L cosine x minus L, and here we have again the convolution where fx minus t is equal to x minus t. So if we say fk, that will give us k. Okay, so we will write L of x, okay, and L of u of x. Okay, and this is according to the convolution rule. So this will give us us equal to 2 multiplied by 1 over s minus 2 s over s squared plus 1 minus 1 over s. This is if it was 1. If it's x, then 1 over s squared us. Okay, again take this us in to the other side, so this will give us us multiplied by 1 plus 1 over s squared equal to 2 over s minus 2s over s squared plus 1, and here we can write it s squared over s squared plus 1 over s squared, which is s squared plus 1 over s squared. So we multiply by s squared over s squared plus 1 for both sides to get u of s by itself in one side, and this will give us 2 over s multiplied by s squared over s squared plus 1 minus 2s over s squared plus 1 multiplied by s squared over s squared plus 1. Okay, and this will give us 2s squared over s squared plus 1, as this will go with that, minus 2s raised to 3 over s squared plus 1 for all squared. Okay, now let's multiply here up and down by s squared plus 1, s squared plus 1. Okay, and this will give us us equal to s squared plus 1 for all squared, and for up 2s raised to 3 plus 2s raised to 4, not 3, plus 2s, oh sorry, it's not squared, it's just s. So this is just s. So here it is 2s raised to 3 plus 2s minus 2s raised to 3. And this will go with that. So we have us equal to 2s over s squared plus 1 for all 2. And this is nothing but the f of s for x sine x. So when we apply L minus 1, we will get immediately u of x equal to x sine x. Okay, that's it. So there is no minus here.